What are the components of a geothermal system? Have you ever wondered how we can harness the Earth's natural heat for energy? In polar regions like Iceland, geothermal energy plays a vital role in sustainable living. So, what are the components of a geothermal system that make this possible? Let's break it down. First up is the ground loop. This is a network of pipes buried underground, usually made from durable plastic or copper. The ground loop circulates a fluid, which is often water or an antifreeze solution. During the cold months, this fluid absorbs heat from the earth. When the seasons change and it gets warmer, the fluid releases heat back into the ground. The constant temperature below the surface is essential for efficient heat exchange, especially in places like Iceland, where temperatures can drop significantly. Next, we have the heat pump. This is the heart of the geothermal system. It transfers heat between the fluid in the ground loop and the building's heating or cooling system. When you need heat, the heat pump extracts it from the fluid. Conversely, when cooling is required, it injects heat back into the fluid. The heat pump also includes compressors and fans to help regulate temperature and airflow effectively. Moving on, we have the distribution system. This component is responsible for moving the conditioned air or water throughout the building. You might find traditional ductwork for air distribution or radiant floor heating systems that warm spaces from below. In some systems, geothermal energy is also used to provide hot water, making it even more efficient. Finally, there is the control system. This includes thermostats and control units that manage the operation of the heat pump and fluid circulation. These controls ensure that the system responds to temperature demands and operates efficiently. In polar regions, geothermal systems are especially beneficial. They utilize the Earth's internal heat, which remains stable regardless of extreme cold temperatures outside. For instance, Iceland has successfully implemented geothermal district heating systems that supply warmth to homes and businesses. This reduces reliance on fossil fuels, which can be costly and less sustainable in harsh climates. The geothermal heat comes from deep within the Earth's crust. This heat is produced from the radioactive decay of elements like uranium, thorium, and potassium, along with residual heat from the planet's formation. This internal heat helps maintain subsurface temperatures that geothermal systems can tap into. In practical terms, geothermal systems in polar regions offer a reliable, quiet, and low-maintenance alternative to traditional heating and cooling methods. They help cut down greenhouse gas emissions and provide resilience against harsh climates by using a stable and renewable heat source found beneath the ice and soil. Overall, the components of a geothermal system, ground loop, heat pump, distribution system, and control system, work together to convert the Earth's steady underground heat into usable energy. This makes geothermal energy an effective solution for sustainable energy needs in polar regions.